Have you ever paused to unravel the enigma of the cosmos, or to question the unseen tether that binds us to Earth, the enigma of gravity? Our comprehension of gravity has dramatically progressed throughout history. We've always embraced it as an invisible power that draws objects with mass towards each other, a concept which enabled us to comprehend why apples descend from trees and why we aren't drifting into the cosmos. But in typical scientific fashion, an unexpected twist was thrown our way: the concept of general relativity. This groundbreaking theory, proposed by Albert Einstein in the early 20th century, offered a completely novel perspective on gravity, shaking the very bedrock of our understanding. It suggested an idea almost inconceivable: that gravity isn't merely an invisible power, but a distortion of space and time itself. Yes, you heard it right. The very fabric of our universe bends and flexes under the influence of mass and energy. And what if we propose that gravity isn't merely an unseen force, but a distortion of space and time itself? Imagine the universe as a fabric. Now imagine placing a heavy ball onto this fabric. The ball, by virtue of its weight, creates a dent, a curvature in the fabric. This is how massive objects, like the Sun or a planet, behave in the universe. They warp the fabric of space-time around them, creating a gravitational field. Now picture a smaller ball rolling on this fabric. It naturally falls towards the larger ball, not because of a mysterious force pulling it, but because it's following the curvature, the dent created by the larger ball. This is exactly how planets orbit the Sun or moons orbit their planets. They're not just being pulled by gravity, they're following the curved paths in space-time created by these massive objects. Einstein called this space-time curvature. This warped fabric, my friends, is the essence of general relativity. Sounds fascinating, doesn't it? But how do we know that this isn't just a figment of Einstein's imagination? Well, let's look at the evidence. First up, light bending around the Sun. Einstein predicted that massive objects like our Sun should bend the path of light. And sure enough, during a solar eclipse in the early 20th century, British astronomer Arthur Eddington observed starlight curving around the Sun, just as Einstein predicted. Next, we have the existence of black holes. These cosmic beasts are regions where space-time curvature becomes infinite. Sound far-fetched? Well, in 2019, the first image of a black hole was captured, providing compelling evidence for these space-time gobblers. And finally, the detection of gravitational waves. These are ripples in space-time caused by accelerating masses like merging black holes. In 2015, gravitational waves were directly detected for the first time, offering further validation of Einstein's theory. These observations, once mere predictions, are now the undeniable realities of our universe. So, we've established that general relativity is more than just a theory. But what does it mean for us? Well, in the grand scheme of the cosmos, it's crucial for understanding the behavior of celestial bodies. It provides the framework for calculating the precise trajectories of spacecraft, making it possible for us to explore the final frontier, space. But it's not just about the cosmos. Even on a day-to-day basis, general relativity plays a significant role. You see, our global positioning systems, or GPS as we commonly know them, rely on this theory to function accurately. Without accounting for general relativity, the GPS signals would accumulate errors, making the system virtually useless. So this remarkable theory, born from the intellect of Einstein, has a profound impact on our lives, from exploring the vastness of space to helping us find our way home. So, the next time you use your GPS to navigate, remember you're relying on the genius of Einstein and his theory of general relativity.